Hello and welcome to a mineral information video. We're looking at different ways to identify minerals, and today we're concentrating on the hardness. There is a scale from 1 to 10 which is known as the Mohs scale, and that was named after Friedrich Mohs, a German geologist. He devised this scale of 10 different minerals, each one of them harder than the other. We start off with number 1, the softest mineral, talc. This is what talcum powder is made out of, basically. It's a very soft mineral. And then we go on to number 2, gypsum. This particular variety is called satin spar. Number 3, calcite. This is one specimen which I collected myself, so I felt it had to get included. Then we go to number 4, fluorite. Nice purpley coloured cubes. Then number 5, apatite. Interesting fact on this is that this is what your teeth are made out of, and I think it's also in your bones as well. And then number 6, Orviclase feldspar. Although because there are feldspar is a group of minerals, the main groups being orviclase and plagioclase. I don't know if this is orviclase or plagioclase, but it's a type of moonstone. It's got a moonstone schiller to it, which I think makes it more orviclase than plagioclase. Anyway, then number 7, a mineral that a lot of people know, quartz. Nice double terminated crystal. And then number 8, topaz. In this case, the yellow imperial topaz variety. And then number 9, corundum. This is actually a ruby crystal. And there's another interesting fact for you. Ruby and sapphire, 2 well-known precious gems, are actually the same mineral, corundum. It's just that ruby is the red variety and sapphire is the blue variety. Well, in fact, actually sapphire can be any other colour than red, but it's all corundum, which is aluminium oxide. And that's number 9. And then finally we come to the girl's best friend, diamond, the hardest mineral there is. Nice little octahedral crystal. But hardness can be deceiving, because that doesn't mean that if I was to take a hammer to that diamond, it wouldn't smash it. Of course it would, just the same as it would smash any other thing. It's more to do with how tightly the molecules are binded. It's more to do with scratching. If one can scratch the other, then it's harder. But it's not to do with how easily it breaks. In fact, some very hard minerals can break very easily, but that's a different story, which I'll probably cover in a later video. But I just wanted to give a quick and easy introduction to the Mohs scale. And I should also point out that these particular specimens are quite good representations of the actual minerals in the field. They're not always that easy to tell apart. I mean, they all look quite different, so you might think, why would you need to do, tests to find out which is which, because they all look different. But if you have a poor quality specimen, it can be hard to tell the difference. So there you have it, the Mohs scale.